As if home automation wasn't fun enough already. In this video, I'm going to show you how I turned some of my home automation components into a game. I'd like to say it's for the kids, but I'd be lying. It's for me.
Whoa!
Ah, greetings, brave adventurer! There is a dragon guarding treasure, and only this wand can defeat him. To get the wand, you must charge it with a spell of fire or ice. Retrieve the dragon egg and heat it to charge the blast of flame, or cool it to charge with the ice storm spell.
What's an ice storm spell? I don't know. I think it's a spell that goes to an ice spell.
Well done! Now approach the dragon, but move slowly and quietly. If you wake him, his fiery breath will be your doom. With the fire spell, touch the tip of the wand to the flame emblem on his chest.
Wow.
I know a magician's not supposed to reveal his secrets, but I'm not a magician. I'm a wizard, and a wizard can do whatever he wants. So let me show you how I did it. This is how our little quest works. There's a wand locked in a box, and there's a dragon guarding a treasure. The only way to defeat the dragon is to get the wand. To get the wand, the kids are going to have to either warm up or cool off a temperature sensor past a threshold. Once they get the sensor either hot enough or cold enough, it'll unlock the box and they can get the wand. Once they have the wand, they need to sneak up on the dragon. There's a motion sensor that's going to let the dragon know that they're coming. They'll get one warning, but then he'll go back to sleep. The second time they activate the sensor, he'll wake up. Nothing really happens. He just kind of yells at them, and then they're going to have to hurry up and touch him with the wand. If they used heat to get the wand, then there's a symbol of a flame on his chest. If they used cold to get the wand, there's a symbol of a snowflake. When they touch the wand to the right symbol, there's a magnetic switch that activates the spell that defeats the dragon. Once they've defeated the dragon, they can move on and try and open the chest, which has a bit of a puzzle of its own. I'm going to break this up into two videos. The first one will be about the WandBox, and the second one will be about the dragon. This is a quick list of the parts I used to make the WandBox. A D1 Mini running Tasmota, a push button, some RGB LEDs, a temperature sensor, a relay, and an old computer power supply. If you hadn't ever heard of it before, Tasmota is an Arduino sketch that's made for guys like me that don't know much about Arduino sketches. It lets you work with a Wi-Fi chip enabled device, like the D1 Mini, to manage inputs and outputs without having to write your own sketch. Some drop-down menus and a few simple commands from the console, and you can do pretty much anything you want. To put Tasmota on the D1 Mini, I'm going to use the same process that I use for all the Sonoff devices. I'm going to use Sonoff.bin and FlashEasy. I'm not going to go through where to get FlashEasy and where to get Sonoff.bin since I've done that about 50 times in other videos. If you haven't seen me do it before, there's a link. This is the D1 Mini connected to a micro USB cord. Just plug it into a USB port on your computer. You don't need an FTDI adapter and you don't need to put it into programming mode. Now start FlashEasy. It already detects the COM port. That's a good sign. Pick Sonoff.bin and Flash. And there we go. And Flash complete. Excellent. Okay. Now, you can connect to it with Termite, just like I've been doing with the Sonoffs also. There it is. It's working. You can now put in a backlog command to put in your Wi-Fi SSID and blah, 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 blah. Or you can wait for it to go into AP mode and then look for Sonoff Wi-Fi address and connect to that to put in your Wi-Fi SSID and password. This is all the same stuff we've done before. Let's get on to some new stuff. Now with Tasmota on our D1 Mini, we're ready to connect all of our parts. This is how I have all the parts connected to the D1 Mini. Because I'm using a power supply from an old computer, I've got 12 volt and 5 volt power that shares the same ground. My LED strips use 12 volts, and the magnetic door lock uses 12 volts. The positive wire from my 12 volt power is represented by the yellow line. The gray lines are all the grounds. This red line here that goes from the magnet to the relay is on the normally open contact of the relay. The other connections from the relay are 5 volts from the D1 Mini, a ground wire that's connected to all the other ground wires, and the data wire that's connected to the D1 pin on this relay module. There's really only one input pin on a relay module. This happens to be a shield module that's supposed to fit on top of the D1 Mini, so the pin I need to use is the one marked D1. If you use a different relay, that'll be different for you. The wire that goes from the D1 pin on the relay goes to D6 on the D1 Mini. For our strip of LEDs, the data wire goes to D8 on our D1 Mini. The temperature sensor requires 3 volts and ground and a data wire. Again, all our grounds are just connected together. The 3 volt wire comes from the 3 volt pin on the D1 Mini, and then the data wire is connected to D5. The last connection is for the push button that's going to get the whole quest started. One wire goes to ground, the other to D4. I'm powering my D1 Minis with a USB cable, but you could also just provide 5 volts and connect it to the 5 volt pin. I've done that before and haven't had any problems, but I did find a post that says if you connect to that 5 volt wire to supply power to your D1 Mini, that may be the cause of any flickering you see in your LEDs. So just to avoid any of that, I'm powering mine from the USB port. That's all the hardware connections. Now we can power it up, then we can go back to Tasmota and finish the software setup. In my effort to make it as simple as possible for somebody to repeat this project, I have put together a backlog command that will set up the D1 Mini for the Wandbox with everything that you need. However, you will need to update the backlog command by putting in your Wi-Fi SSID and password and your MQTT broker information. The only other thing that you might change would be the temperature module type. I used an AM2302. If you use something else like a DHT11, then you'll have to change that module type in the Tasmota settings. But that's not very hard to do. Everything else you should be able to leave the same. Once you have all your settings put in to Tasmota, this is what the web user interface will look like for the Wandbox D1 Mini. If we go to the configuration and configure module, we can see how all the pins are assigned to the different inputs and outputs. With Tasmota, when you're using something like the D1 Mini or a Node MCU board, the module type you select is generic. Then you can see that what I had on the fritzing diagram matches up with what you see here for which pins are assigned to which inputs or outputs. D8 for the RGB LEDs, D5 for the temperature sensor, Relay 1 is the relay that controls the magnetic lock, and switch 2 is on D4. That's the push button that starts everything off. One important thing to know with Tasmota, if you're going to put in more than one switch, you need to also put in a relay, even though that relay doesn't really exist, and that pin isn't really connected to anything. So in order to get switch 2 to show up and function, I needed to also add relay 2. I hope that makes sense. The only function of switch 2 is to send an MQTT message. Got it? Good. So we've got Tasmota set up, and we have our hardware set up. Now we can set up the stuff we need to do in Home Assistant. In your Configuration.YAML file, you're going to need some switches. I'll make all of this available to you so you can just copy and paste. But let's walk through so you know what's happening. We're creating a switch for the Wandbox lock. That'll be connected to relay number 1. So the topics will end with power 1. We're creating a switch to start the quest. We set that up as switch number 2, so the topics will end with power 2. These other 2 switches are part of the dragon setup, but you can go ahead and include them now. This is what's going to make the dragon die when it gets zapped with the ice spell or the fire spell. Next, we need to include a light entry for the Wandbox and for the dragon eye. These are the command and state topics that you need to have full control over RGB lights in Home Assistant. There's a pair of topics for on and off, another for the RGB or color control, and another pair for the brightness control. Now we need to include a few input booleans. The purpose of these is to make sure that the quest progresses in the right sequence. I want to make sure that the dragon doesn't activate, that he's detected movement, before the players have actually obtained the wand. So these input booleans are how I accomplish that. At the end of critical steps, an input boolean gets turned on. And in order for the next step to occur, that input boolean has to be on. If it's off, then subsequent steps will not occur. That'll make sense when we walk through the automations. For now, these are the input booleans that you need. And then we need one binary sensor, which is the motion detector for the dragon. And the last thing I set up in the configuration is the temperature sensor. Now the fun part is the automations. Here's what you need for the automations.YAML file. I think probably the most important part of this whole thing is how to make these automations work. Without this, nothing really happens. The first automation here is what happens when we press the button on the back of the box that starts the quest. The trigger is the switch start quest going on. It's a momentary button, so when you press it, it just goes on for a second and back off. But that's all it has to do to start the automation. And that sets off several actions. The first is to play a recorded sound file through the Volumio box. This gives the players some initial instructions on what they need to do. To get the sound files to play, I created them just using Final Cut Pro and a microphone. Then I put those audio files on my Volumio Pi. Then I created a playlist for each file that includes just that file. I'm sure there are other ways to do this, but this is how I did it. And it works. The other actions are to make sure that the box that holds the wand is locked, that the dragon eyes are turned green, and that the lights in the wand box are displaying a cool variety of colors. And finally, we turn all of our input booleans to off, which resets any of the previous detections or other events that may have happened when the last person went through the quest. That's automation number 1. Automation number 2. The trigger for this automation is the temperature sensor reporting a temperature above whatever threshold you set right here. When that happens, the lights inside the wand box will turn red. The wand box will unlock. Another pre-recorded sound file will play, telling the players congratulations, and again, what they need to do next. And finally, we'll turn on the input boolean that says the wand has been obtained, which is essential for activating the motion detection in the dragon. The third automation is a repeat of the second, but instead of having a threshold for temperature above a certain degree, this one is for a temperature threshold below a certain degree. This is the ice spell. When it's activated, the lights turn blue, the box is unlocked, the ice spell sound file plays, and the wand obtained boolean is turned on. Now the player's ready to continue to the next step. This automation will set the wand box back to a variety of colors if the temperature drops back into the space between the two thresholds. I wanted to make it so that there was a second person involved in the quest. That person's role is going to be to make sure that the temperature stays above or below the threshold. If it falls back into this middle realm, the lights will change on the box, and the spell that's supposed to be in the wand won't actually work when you try and attack the dragon. That's all for the setup for the wand box. Because we've changed our configuration.YAML and our automations file, we want to go back to Home Assistant, to the configuration tab, check the config, and then restart everything. Checking this config is pretty important. If you don't do it and you've made a mistake, you won't be able to get back into Home Assistant. Well, that's all there is to setting up the wand box. Next time, we'll set up the dragon. We've already started working on building him, and I already have the sensors and things set up and working. It's only a couple weeks till the Maker Faire, September 15th at Thanksgiving Point in Lehi, Utah. If you can come, be great to see you there. If you can't, I'm sure we'll find a way to live stream and let everybody join in and at least see what's going on. This has been a really fun way to make new use out of our home automation sensors and switches, etc. You could really turn your house into a game. That'd be cool. Once again, here's all the important links that you need. That's all for now. As always, thanks for watching. Until next time, adios.